Hi everyone, welcome back to our YouTube channel Electro Study. This is lecture series 14 under computer networks dealing with network layer. Come, let's go into the video. Please do like, share, comment and subscribe. In previous videos, we have seen about what is data link layer, what are all the protocols followed in the data link layer, and we have seen about the random access, different types of random access control and the protocols, important Ethernet protocols. Now we are going to the next layer of OSI model, that is the network layer. So this network layer is the third layer of the OSI model. What is the important features of network layer? So it is responsible for all the requests that is taken place from the upper layer of the protocols, that is transport layer, application layer, takes the request from the upper layer protocol, transfer it to the lower layer protocol, and the same vice versa is done. And it translates the logical address into physical address. Logical address from the data link layer to the physical address in the network layer, and it manages all the traffic problems that is occurring in the network like switching, routing, error control, etc. And there is a main role that is performed by the network layer, that is the movement of packets from the sender to the receiver. It ensures that all the packets that is forwarded from the sender reaches the destination at a particular interval of time, and the receiver returns back an positive acknowledgement to the sender. So these are the important features under network layer. Now we will be seeing about the services provided by the network layer. There are many services provided by network layer: internetworking, packetization, routing, fragmenting, and there are routing protocols followed for routing. So these are some services that is provided by the network layer. So here from this diagram, you can know that the network layer receives services from the data link layer and it provides services to the transport layer. So these are the services that is provided to the upper layer protocols. Packetizing. So this is one of the central issue of the network layer. That is, see, here you have upper layer protocols, that is application, transport layer, network layer and data link layer. On the destination side also the same layers is being followed. Now what happens is, when you say packetizing, remember two words: encapsulation and decapsulation. That is, it encapsulates all the data from the transport layer and it receives in the data link layer. Now when from it is traveling in the destination path, all the encapsulated data are decapsulated at the destination end. It makes sure that all the payloads that is formed in the source end is encapsulated and all the payloads that is received in the destination is decapsulated. The example that I can give for packetizing is post office. So in post office, how the function is, you send a letter with from and to address. So seeing the from address, it is sent to the destination through a hub called as a post office. Now the postman delivers the letter to the receiver without reading the content. So same happens here. Whatever payload is formed in the source is completely received in the destination. There is no change of content that is happening through the traveling medium, right? Next is routing and forwarding. Now what is routing? It is the process of selecting a path for the transmission. Forwarding is nothing but after finding the route to be traveled, it is a form of action that is performed. So that is, the frames are sent from one end to the other end, or the datagrams and the network layer is sent from one station to the other station. See now how routing is performed. You have A station and B station. You have 5 routers here. Now, to transmit a datagram from station A to station B, it takes many routes. It can follow A, R1, R3, R4, R2 and B station, or it can directly pass through A, R1, R2, B, or it can take any of these routes that is connecting to the destination. So it performs some algorithm, routing algorithms inside this, and it finds the shortest path to transmit the data to give a good performance of the system. So now, if it is routing the data through one from one end to the other end through a shortest path, now it is the values are stored in a table called as local forwarding table. See here, routing algorithm is performed, and the action that is performed, what is the action or the output that is performed, is stored in local forwarding table. That is, this is the payload's header value, that is source address or the destination address from where the packet is originating. The value of header value will be specified here. So for this header value, what is the data that is transmitted to the destination? So the pocket having a header value 0100 is the value holding 3. Same ways it goes for all other values. All these header values and the output values will be stored in local forwarding table. There are some other services provided by the network layer, that is error control, flow control, congestion control, and the quality of services security. What is error control now? It will ensure the quality of services provided over the network connection. That is, this network layer doesn't have any particular algorithms or protocols to be followed to control an error. All the errors will obviously be controlled in the data link layer. Some of the residual errors, even after controlling the error in the data link layer, there are some residual errors that is present in the pockets. So that errors will be completely cleared and detected, or it will be notified in the network layer through the error control. Next is flow control. In flow control, what happens is it regulates the amount of pockets of data to be sent from one end to the other end. It doesn't send n number of datas at one time. The flow is once a data is sent from the sender, it will wait such that the receiver is getting the data and acknowledging back. After the acknowledgement is received, the next data is ready to transmit in the network. So the flow control from the upper layer protocol also is performed, and also it is performed from the lower layer protocol. So when all the layers are performing the flow control, the whole system becomes inefficient. That is, every layer will be waiting for the pocket for n number of time, then obviously the performance of the system reduces. Okay, next is congestion control. Congestion control is there is a capacity for the network transmission path to hold the data. Too much of data should not be present in an area. If too much of data is present, that is, if data that is present in the transmission medium exceeds its capacity, then it will be reaching a point where the system completely collapses and no datagrams are delivered to the host end. And quality of services. So quality of services is when you perform different services, it should be suited for each and every application that is running in a layer. Nowadays we are using many advanced applications like multimedia application, voice recognition, artificial intelligence based applications, many things we are using. So to control all those in a network, you need a very good quality services that has to be provided, such that it should give you better quality of service, and also it should safeguard the complete application that is designed in a network. Next is security services. So in this layer, the security services, how it is performed is when the data is reaching the destination node, the payloads is completely decoded and it is seen that whether the accurate data is being achieved or not. So for security purpose, in the before layer only, the checksum is performed. So with that checksum, with the help of the error control, it ensures that the complete security is provided for the whole data that is transmitted from one end to the other end. Got it? Thank you. Stay tuned for more information. Next video will be upon the different approaches that is followed in the network layer. So stay tuned for more information. Thank you.